Okay, let's take a look at linear versus exponential models. Okay, so first of all, when something has linear growth, it means that the same amount is being added or subtracted, okay, to your initial amount. Okay, something's being added or subtracted. The general form of this is y equals mx plus b. So we have our starting amount right here. B is usually the y-intercept, or where you start. That's your starting. Okay, and then m was your slope. That was your rise. So that was how much you were changing. So m was your change. Now I know it was the slope. Okay, if you look at the graph, you go up 2 over 1, up 2 over 1. It would be like me adding $2 to your bank account every month. Okay, for example, you start with $50 and you earn an additional $100 every day at work. So you have $50 and then you add $100 and then you add $100 and then you add $100. Okay, so the initial amount, 50, that's going to be your b, your y-intercept, and then this is your change. Up 100 over 1, up 100 over 1. So the equation would be y equals 100x plus that initial 50. 50 doesn't change. You start with 50, that's your b, your y-intercept. Okay, but then you keep adding an additional 100 every day. So x would be the number of days at work. And if you worked for 5 days, you would add 100 5 times. Okay, so this is linear. Y equals mx plus b. If something is being added, your line would be going uphill. If you're subtracting, then your line would be going downhill. So there's 2 ways your lines can look. Okay, your graph could be like this, uphill or downhill. But that's what happens when you're adding or subtracting. Okay, exponential models are a little different. When something is being multiplied or divided to your initial amount, okay, then we call it exponential. It would be y equals a times b to the x power. And only b gets the x power. Okay, a, this is your starting amount or initial amount. Sometimes they say initial because that's the word for starting. Okay, and then we multiply by b. So this is the thing that you multiply by. And if I divide by 2, that's like multiplying by a half. So we're always going to say multiply. For example, you start with $1. And then every day you double the amount. So I have $1. And then I times that by 2. And then I times that by 2. I times that by 2. Times that by 2. Every day you double the amount. Okay, that's going to start to get to be a lot of money. So the formula would be y equals, the starting amount is $1, and then we multiply that by 2 to the x power. Okay, and x would be the number of days, okay, that you multiply it by. If I multiply by 1, 2, 3, 4 days, then I would put a 4 there. And that would be 4 2s. Okay, so this is exponential. And here's the formula that we have to learn for exponential if you're multiplying or dividing. Okay, I'm going to walk you through a couple examples. Hopefully it starts to make sense. Okay, we have to read the situation, and then we have to decide whether it's exponential or linear. Okay, and then we have to explain why. So for this first example, we have a library has 8,000 books. Okay, and it's losing 3 books every year. Maybe they get ripped or maybe they don't get returned. Okay, so I have 8,000 books, and then I lose 3 books after the first year. I lose 3 books. Let's subtract. I minus 3 books. Every year I keep subtracting 3. Okay, this would be linear. And explain why you choose that. Okay, because they keep subtracting. They keep subtracting 3. Adding and subtracting is linear. Okay, let's go ahead and write an equation for this situation. So for linears, we're going to use y equals mx plus b. Okay, and what we're going to have here is y equals, here I'll write y equals mx plus b. Remember b, okay, b is the starting number. B is the starting number and m is the change. Okay, so our change is negative 3, down 3. Negative 3 times every x. Okay, and so what's an x? X is, let's say I lose 3 books every year. So x is the number of years. Number of years. If it's 3 years, it would be negative 3 times 3, 3 times. If it's 10 years, it would be negative 3 times 10. And then the b value, the starting number, was 8,000 books. Okay, and what's y? This equation is for total number of books. Okay, total number of books, and then x is the number of years. Now they want us to use that equation. Determine the number of books they will have left after 10 years. Okay, and so x was for my number of years. I'm going to put 10 into the negative 3 spot. So y equals negative 3. I'm going to put a 10 there. Are they going to lose 3 books 10 times? Yeah, because they lose 3 books every year. So if I do that for 10 years, okay, and the initial amount was 8,000. So we can go ahead and use our calculator if you need for this. Okay, and you can just straight up type it in negative 3 times 10 plus 8,000. And it says I have 7,970 books. Okay, does that make sense? Yeah, it's less than 8,000. The number of books went down. I lost 30 books. Okay, and this would be linear. Okay, so hopefully this is stuff you guys studied last semester. All right, let's look at example number 2. A bank account starts with $10. Okay, so let's see. Let's just kind of write out our idea here. I have $10. Every month, the amount of money is tripled. Tripled means I'm going to take my money, I'm going to times it by 30, triple it. I'd have 30. And then the next month I triple my money again. And the next month I triple my money again, dot, dot, dot. Okay, so every month it's times by 3. All right, so is this linear or exponential? Okay, I'm going to say it's exponential. Okay, and the reason is because every month the money is tripled. You could say tripled, or you could say multiplied by 3. There's the key word. If you say the word multiply, pick exponential. Okay, so now I have to make an equation. The formula is y equals a times b to the x, and my initial amount is a. Okay, so the initial amount we start out was 10. So you put your beginning amount there, $10, and then we're going to multiply by 3. Multiply by 3, because that's the pattern. But we don't just do that one time. We multiply by 3 over and over. Okay, and so what does x represent? We have to define our variables. X is after x months. So if it said after 3 months, I would make x be a 3. After 0 months, if I didn't have any months, I would just have that $10 in the beginning. And y is total amount of money in the account. So whatever we keep multiplying by, that's your b. And then x is the amount of times you do that. Use your equation. to determine the amount of money you would have after 6 months. Okay, because you start with 10, and then we times by 3, times by 3, times by 3. So I'm going to make x be a 6. So my equation would be 10 times 3 to the 6th power. And that means I would have 3 times 3 times 3, 6 times. That makes sense. After 6 months, you have to keep tripling your money. So when you type this in, make sure that the 3 only goes to the 6th. You could do it a couple of ways. You could type it straight up. 10 times 3 gets the power of 6. Okay, or you could type 3 to the power of 6. Take that answer and times by 10. Okay, but what you do not want to do is multiply 10 times 3 and make a 30 and give 30 a 6th power. Only 3 gets the 6th power. Remember, please excuse my dear Aunt Sally. Remember, exponents have to come before multiplication. So y is 7,290. Okay, and this is dollars. Okay, I need to see your exponential model, your equation, okay, and then the answer. With something like this, I guess we could check. I could take 10, and if I times it by 3, so after 1 month, after 2 months, after 3, 4, 5, 6 months, that's right. Okay, if I asked you 1,000 months, it would be totally different. We'd have to do the formula for sure. Okay, so in this chapter, make sure I see your equation, your exponential equation, and your answer. We always have to state our variables, what they represent. Okay, let's take a look at the last example. There are 20,000 owls in the wild, and every decade, the number of owls is halved. Halved. Halve means divide by 2. Okay, dividing by 2, or it means times by a half. Is that true? What's 10 divided by 2? 5. What's half of 10? 5. Okay, so we always use the fraction form. This is definitely exponential, okay, because we keep multiplying by a half. Okay, or you could say because it keeps dividing by 2. All right, but we're going to do the 1/2 because the formula for exponential is a times some b number to the x. So we have to say the times 1. We have to use the half. It's halved. So there's 20,000 owls. I'm going to write down my idea here. And then I multiply by half. Then there's half as many. And then the next decade, it's times a half. The next decade times a half, ... Okay, so what is the initial amount? So 20,000 goes out in front. And then b, your multiply number. Okay, it keeps getting cut in half. 1/2 to the x power. Well, what does x mean? I keep multiplying by a half. How often? How often does it get halved? Every decade. So x equals, okay, the number of decades. Decades. Do you guys know what a decade is? Okay, a decade is 10 years. Every decade. X is the number of decades. And then what does y represent? This equation is for the total number of owls. All right, so there's a lot of work here. Write the equation, check. Make sure you define your variables, check, check. Use your equation to determine the number of owls after 80 years. Okay, so we have to be careful because we're not going to multiply by a half 80 times, are we? It said it gets halved every decade. So 80 years is how many decades? That's 8 decades. That's 8 decades. So we're going to plug 8 into the equation for x. So y equals 20,000 times by a half to the power of after how many decades? 8. So we've got 20,000 times, I'll use my fraction button, 1/2, and that is to the power 8. And the answer is, I don't know if I want a fraction of an owl. 625 divided by 8, there's approximately 78.125 owls. Okay. Of course, there's not going to be a fraction of an owl, but this is predicting about 78 owls are going to be left. So they're probably on the endangered species. Okay, thank you.